All right, so hopefully you've gone and practiced balancing in an acidic half reaction, because now to balance a basic half reaction is only one more step. To balance a basic half reaction, you do all the same steps you would to balance an acidic reaction. So you balance the majors, you balance the oxygens with water, you balance the hydrogens with hydrogen ions, and then you balance the charge with electrons. And then one more step. You're going to adjust for a basic solution by neutralizing the hydrogen ions using the ionization of water. So you will either use hydrogen ions and hydroxides form water, or water forms hydrogen ions and hydroxide ions. So looking at this reaction from above, we have our balanced acidic reaction, and we want to balance out the 4 hydrogen ions and make them into hydroxides. So because the hydrogens are on the right, you're going to do the formation of water. So you would do that 4 hydrogens plus 4 hydroxides forms 4 waters, so that you can cancel out the 4 hydrogens. Now be careful as well. Now we have waters on both sides of the reaction, so these 2 waters would simplify the 4 to a 2. So that my overall reaction would be MnO2 plus 4 hydroxides forms MnO4 minus 2 waters and 3 electrons. Remember, this is a half reaction, so we have to include our electrons. To double check that I'm good for mass and charge, you would count up your oxygens and your hydrogens. So on the left, and your manganese. So I have 1 manganese on each side. I have 2 oxygens plus 4 oxygens makes 6 oxygens. On the right-hand side, I have 4 oxygens and 2 oxygens make 6 oxygens. On the left, I have 4 hydrogens, and on the right, I have 4 hydrogens. And then my total charge on the left is -4, and my total charge on the right is -1 plus -3 is -4. All right, let's give these a go. So first thing you're going to do is balance your majors. I have 1 lead on the right, I have 1 lead on the right, or you know what I mean, 1 lead on the left and 1 lead on the right. This noise is making my brain stop working. Okay, and then on the right-hand side, there's 2 oxygens, so I'm going to balance that by adding 2 waters to the left-hand side. And then I'm going to balance my hydrogens. So remember, major hydroxide. So majors, oxygens, hydrogens. I have 4 hydrogens on the left. I have 1 hydrogen on the right. So I'm going to add 3 hydrogens onto the right. And then I'm going to balance for charge. On the left-hand side, I have a total ionic charge of 0. And on the right-hand side, I have -1 plus 3 is +2. To balance this out, I need to go down by 2 to make a total ionic charge of 0, which means I'm going to add 2 electrons on the right-hand side. Now, I shouldn't have written anything below. Hopefully you didn't, because now I have to balance this for basic. So this is balanced in an acidic solution. To balance this for basic, you have to switch the hydrogens to hydroxides. So I have 3 hydrogen ions on the right. So I'm going to put 3 hydrogen ions on the left, plus those 3 hydroxides, forming 3 waters. So that my overall reaction, the 3 hydrogens will cancel out, and the waters, my 2 waters, will take this and make it 1 water. So on the left-hand side, I have lead, plus I have 3 hydroxides, forming this HPbO2, and then I have 1 water, and I have 2 electrons. And when I'm marking your test, I don't care what order that you've got your stuff written in, as long as all the appropriate things are on each side of the table. Okay, so how about the next one? First thing we're going to do is balance for majors. I have 2 nitrogens on the left, and I have 2 nitrogens on the right. So then I am going to move to my oxygens. So my oxygens, there aren't any. So then I get to move to my hydrogens. So sometimes there aren't oxygens, but there still are hydrogens. So I have 4 hydrogens on the left, so I'm going to add 4 hydrogen ions on the right. Then I'm going to balance for charge, so I won't do that again. So this side is 0, this side is +4. So I'm going to add 4 electrons to balance my charge. Then to balance this in a basic situation, I just have to balance out the hydrogens. So I have 4 hydrogens plus 4 hydroxides forming 4 waters and then I look for my overall reaction. So the 4 hydrogens are going to take out the 4 hydrogens. I'm left with N2H4 plus 4 hydroxides will form N2 plus 4 waters plus 4 electrons. And that is me charged in a basic environment. Last one here. Hopefully you're feeling ready to pause the video and give this one a go. First thing we're going to do is balance majors. Then we're going to balance oxygens. Now there's 4 oxygens on the left and 6 oxygens on the right. So I'm going to add 2 waters. Then I have to balance for hydrogens. I have 1, 2, 3, 4 plus 1. I have 5 hydrogens on the left and only 1 on the right. So I'm going to add 4 hydrogen ions. Then I'm going to balance for charge. So on the left-hand side, I have a -1 charge. And on the right-hand side, I have -3 plus 1. So I have a +1 charge. So to the side, I'm going to add 2 electrons, which will bring me down to a -1 charge. Now I'm going to switch from hydrogens to hydroxides. So I have 4 hydrogen ions. I have 4 hydroxide ions. And that's going to form 4 waters. So that my overall reaction, my hydrogens are going to balance. These 2 waters are going to become 2 just on the right. And I'm going to have, so again, doesn't matter the order, but I'm going to start with HXeO4 minus, and then I've got 4 hydroxides. And that is going to form that HXeO6 3 minus. I'm not even going to try to name that thing. And then the 4 hydroxides, I should just, like, what about another color? I didn't want to cross them out so they didn't make things confusing. Right? So I've got this, and then I have 2 waters, and I have 2 electrons. And again, it's always a good idea in the end to just double check that everything is balanced and that your charge is balanced overall, right? So even if I just check charge, I've got -1 plus -4 is -5. And on the right, I have -3 plus -2 is also -5. All right. When we come back, we're going to do total reactions.